Okay, we're starting a new series on electricity for your RV, and we're going to be talking about direct current, also known as batteries.
RV Mentor, RVing for Newbies, ethics disclaimer. All the tools being used, the items being installed or reviewed were purchased by RV Mentor. The only exceptions will be denoted in the next slide in this video, giving the name of the manufacturer, the items, and how they were acquired, donated, etc. The things stated in this video are the opinions of RV Mentor and are just that, opinions, but are based on 13 years of being an RV owner and being an RV inspector. Let's get on with the video.
So we talked a little bit about lead acid batteries. You also have batteries that are called AGMs. And these batteries, notice across the top, there is no maintenance required for them. Okay, they can be hung upside down, they can be hung sideways. You don't have to worry about acid leaking out like you do on the lead acid ones. Now, I want to show you something on this. I'm pulling out the handy dandy voltmeter here. And the reason I want to show you this is yours truly went ahead and let this battery pretty much die over the winter. Put it on charge a couple days ago, gave it a couple of days charge. And even though it was charged and said it was fully charged, you can take a look and see our battery voltage is 7.59. This battery is literally dead. There is no way we're bringing it back. I charged it a couple of times. I killed the cells in it by leaving it out in the cold and not having a charge. That is what will happen to both lead acid, AGM, lithium batteries, doesn't really matter. You will kill them if so. A battery is either charging or it's discharging. It doesn't matter what kind, whether it's AGM, lithium, flooded lead acid battery, it's either charging or discharging. So if you're not charging it, even if there's no draw on it, it will discharge on its own. Keep that in mind when you're talking about your batteries and the health of them. Charge them or have them potentially be discharging all the time. All right, as you notice on the top of this battery, there are a couple of adapters, for lack of a better term. This battery comes with only the poles. Most of your wiring for your battery, when it comes to RVs, I'm grabbing the wires from the other one, come with those kind of ends on them. Something like that. These are the El Cheapo ones, but you get the idea. And so you can't really connect these to here. You have to get an adapter. So keep that in mind when you're looking at your batteries on your coach, on your RV. If you have to have, if there's adapters or if you're going to swap your batteries out, keep in mind to either get the kind that have the poles on them, which are usually your deep cycle batteries, or you'll need to get an adapter. Now, as you're looking at this AGM battery, even though it's dead, basically, for all intents and purposes, it is what's called a yellow top. Can you tell yellow through all the dirt? Yeah, it's pretty bad. Anyway, so on a yellow top battery from Optima, which is who makes this, this is an Optima yellow top. And a Optima yellow top battery is both a starting battery and a deep cycle battery. It can perform both roles. And you'll see when I get ready to talk about the RV batteries in my RV out here as to why I chose yellow tops versus the flooded lead acid battery. I don't like having to do maintenance if I don't have to. Okay, looking at our battery here. We have a couple wires hanging off of it. But let's take a look, since we looked at the voltage of the one that I killed, let's take a look at the voltage of this one. Set your meter for DC 20 volts. And let's see what we got here. 12.25, not bad. This one kind of sat around most of the winter too, but it didn't really kill it because it had a better charge on it than the yellow one did. What we've talking about up to this point are only 12 volt batteries. You have the option, if you want to go with 6 volt batteries, which some people do because it gives you longer power when you're boondocking. Boondocking is a term used by RVers to describe RVing without being connected to water, electric, or sewer. Because you're not connected to any services, it's also called dry camping. Other terms you might see that all refer to boondocking are free camping and wild camping. Your RV battery DC system is 12 volts. So let's take a look at some ways you can power your RV. Most of you probably have one 12 volt battery. Simple enough. let's take a look at some other ways to get 12 volts. Looking at our picture up here, we've got wired in series on the left. This is where you can take two 6-volt batteries, wire them up in a series to get yourself 12 volts. The picture on the right is wired in parallel. That is two 12-volt batteries wired up in parallel, so you still have 12 volts, but you have extended amps to run your RV. Here we've got 12-volt batteries on the left, all hooked up in parallel, so you still get 12 volts. And in the batteries on the right, you've got 6-volt batteries. You've got two of them in two sets. The first set's hooked in a series to pump out 12 volts. The second set is hooked in a series to give you 12 volts. And then the two of them are hooked in parallel to give you 12 volts. So that's how you can take four 6-volt batteries, which you think would normally produce 24 volts, but you're going to get 12 volts out of it. And you can use that kind of a setup to run your RV also. This last picture here we're going to take a look at is the wrong way to hook up a couple of 12-volt batteries in parallel. And the reason behind that is, as you look at those batteries, both the battery on the front has both poles connected to the RV, one to the electrical equipment, the other to ground. That's not the way you want to do it. They become what's known as a parasitic draw. One will, if it isn't as good as the other, there's just a whole lot of problems that can go along with that. So if you were to take where terminal battery A is on the negative side, take that wire and swap it. Take what one's on battery B, put it on battery A, and then ground the other side onto battery B, its negative pole. Then you have a correct connection. Taking a look at the voltage chart here, we range anywhere from anything greater than 12.6 down to 10.5. Notice, between 12.6 and 12.1 is a 50% drop in your charge rate. That's right, a whole 50% for 0.5 volts. So when you're checking out your battery and you want to make sure you're using the voltmeter to see what the true voltage is on your battery, this is the chart you should rely on. If you've gotten down to 11.9, you're already down into the orange range, which means repeated discharges to this level can shorten your battery life. If you let it get down to 11.3, you're going to be ruining it really quickly. So keep an eye on what your voltage is on your battery, and also keep in mind that when you have your battery being charged by whether it's a converter, trickle charge, whatever, when you take that charge off, let it sit for 30 minutes and then measure what the voltage is, because there's a certain amount of droppage that'll happen after you take the charging mechanism off the battery, and you want to make sure it's still going to hover around 12.6 or above. Battery safety. All right, I can't stress this enough. We talked about in the AC side how many milliamps it will take to kill you, and it's not a whole lot. When it comes to direct current, battery sitting there is a lot of amps in these guys. And if you were to short circuit with a wrench or something between the positive and the negative, or grab both ends at the same time, there's a good chance you're not going to survive. So that being said, let's talk about how do we disconnect wires from a battery. The first thing you want to do, if at all possible, is find your battery disconnect switch. It could be inside your door, like on my motor coach. It could be a red switch somewhere in a front cabinet on your travel trailer or fifth wheel, way up front, up near where your batteries are. You want to be able to do a battery disconnect. You don't want sparks. Sparks are bad when you're talking about lead acid batteries, because they put off hydrogen gas, and that is explosive. So I don't have this battery hooked up to anything, but let's take a look at it. Negative. You always take the negative off first. Do not touch the positive while you're doing this. All right? If your house switch battery disconnect switch has been turned off, you should not see a spark when you remove these wires. Once you've got the negatives off, move them, because a lot of times this part's hooked to your RV somewhere. Move them to where they can't be accidentally touching the negative again. Then, if you're doing battery maintenance and you need to take your batteries out, then take your positive off. Now, Hooking them up is exactly the opposite. You put the positives on first. All right, get them pinned down there. You then put the negative on. Now, don't be surprised if you throw a spark when you hook that negative up. That means there's something in your RV. Either your battery disconnect switch isn't turned off, or there's something in your RV that is pulling a draw, whether it's a carbon monoxide detector, your propane detector, a smoke detector, who knows what else. All right? But definitely, if you can find a battery disconnect switch, turn your battery off before you start removing cables. The spark thing, a lot of times it's never going to be a problem. It could cause an explosion, probably not. But you don't, if you're anything like me, you don't like things sparking.